Hi there. My name is Richard Stillman. I'm in a General Chemistry 2 class with Doane University. My professor is Dr. Ken Capps. Today I'll be doing a presentation on an advanced concept called the gummy bear experiment. Without further ado, let's dive in. So here were the instructions. I was to buy gummy bears, soak the gummy bears in two different solutions, one filled with tap water and one filled with a saturated salt water solution. So I was going to add salt to it until I could no longer get it to dissolve by stirring. And I was supposed to leave them for about 6 to 10 hours. These, I kind of split the difference, were taken out around 8 hours. So I took the ones out and I compared them to a normal gummy bear. And we'll get into that and I'll show you guys. Using the information provided in our book, I did some research. I actually found an outside research from the book that really went into what is going on in the solutions and why we're actually doing this experiment. And then I designed this presentation, and luckily I did get some good results. My experiment didn't fail. I did come up with some possible source errors that one could see and where it might not work in certain situations. Alright. So one of the main reasons why we're doing this experiment is to kind of learn about osmosis. Now, osmosis is defined as the flow of water from an area of high concentration to an area of low concentration. Now, with osmosis, there's a thing called tonicity. Now, tonicity, there's 3 different types depending on your experiment or solution or whatever you got. So the first one is isotonic, and I like to think of this as just like the equal, it's the norm. But it's the concentration of the solute in the cytoplasm of whatever thing you're testing, whether it's a cell or in this case it is a gummy bear, is equal to the concentration in the solution. And what this does is the cell or the gummy bear will not lose or gain any water. Now, in a hypotonic solution, the concentration, like in the gummy bear, the cell's cytoplasm, is greater than that of outside in the solution. And what happens with that is the cell, or the gummy bear in this case, swells and it can explode. And we'll actually see these gummy bears and the fact that they're swollen. So, and then hypertonic is the converse of that. It's a concentration of the solute in the solution is greater than in the cell. And what that does is it causes the cell shrinkage and crenation. Crenation is just different, weird shapes, and it's kind of that shrinked appearance, and it kind of deforms whatever was crenated. So, all right, let's move on here. So another thing to discuss is permeability. Now, permeability, these gummy bears in this experiment, they have a semi-permeable membrane. This is because they're non-living. Living people, they have permeable membranes. Water is going to be transferred across the gummy bear's semi-permeable membrane. And then what's going to happen, what we kind of expect in the tap water solution, we expect water that's going to enter the gummy bear, causing it to swell. In the saltwater solution, it's the other way. The water is actually going to be drawn out of the gummy bear towards that salt, and that's going to cause the gummy bear to shrink and kind of morph the shape of it. And we got a little bit of that, but I'll let you guys look here in a little Alright, so this was the experiment details. Just going a little bit further in the instructions. The gummy bears were placed in two different solutions, a tap water and a highly saturated saltwater solution. And then what I did is I used about 4 ounces of water placed in 2 clear cups. Then I added salt to the second cup until the solute would no longer dissolve. The amount of solute I used was approximately 4 tablespoons of salt, or about 60 milligrams. And I used table salt, Morton's. Specimens were then evaluated. This is 6 hours. Actually, I'm doing it after 8, so I can get a little bit better results. Alright, so move on here. Okay, so now we're going to inspect these gummy bears. And the things I'm looking for, I'm going to kind of look at the size, I'm going to look at the shape, the color, what the solution looked like, and anything else I noted. Alright, so let me show you here. I'm going to throw myself up on the big screen here. Alright, here we go. So this is my little thing that I did here to kind of show you guys. So let me make sure it's centered. Okay, so right here we have our normal. As you can see, it's not discolored or anything. It's straight from the package. Now in the center here, we actually have solution 2, which is the saltwater solution. As you can tell, they are a little discolored. The shape, they definitely changed shape. I wouldn't say they necessarily shrunk. That could be part of some of the source errors that I'll mention later. They are a little bit disformed though, and definitely not the size of. This is the tap water solution here on the far right, and as you can tell, they really swelled up. Now I did 2 different ones, so you could. It was kind of easier to see how the green was working. Also, one was basically, this is like actually the 6 hour. The green got added later, and this is the 8 hour yellow. And you can see it's kind of breaking down now. Also, when I pulled it from the solutions, the saltwater solution was very discolored, so it drew out all that dye from the gummy bear into the actual water itself. So I'm going to put this down. Let's press forward here, and I'm going to switch it back here so you can see the presentation. All right. So conclusion, and we'll get to the source errors here at the end, but I'm kind of determining that this is due to osmotic pressure. The gummy bears were soaked in regular tap water. They actually absorbed the water surrounding it, drew that into it, because the gummy bear was actually the area of low concentration. And then conversely, the salt-saturated specimen drew out all the water from the gummy bear. So it was kind of as predicted. My hypothesis, what I thought would happen. So, the addition of salt changed the solution to a hypertonic solution. So therefore, the concentration in the solution was lower. As we have learned, osmosis is the movement of water from one area of high concentration to an area of low concentration. In this case, the area of high concentration was the gummy bear in the saltwater solution, and the area of the low concentration was the saltwater solution itself. Alright, and let's get to the source errors. So these are the things I think that could actually impact the experiment and where you might not get the best results. Maybe why we didn't see complete shrinkage. First is the length of saturation time. So I took them out at like a 6 and an 8 hour time period. if I would have gone 10 hours or even a day or something like that, I might see different results. I might actually see a complete breakdown of the tap water specimen. I also might see shrinkage due to that time from the gummy bear soaked in saltwater solution. And then the type of the gummy bear. So I used, see, they're Haribo Gold Bears. I think that different types of gummy bears might have a different consistency of the polymer in the gummy bear. So I don't know how if that could affect it, but it does seem like it would. And then using tap water instead of distilled water. So, and I can imagine that everyone's tap water is different, and then they have certain chemicals and stuff added to tap water to make it safe for drinking. So that could affect the experiment. Um, and then the type of salt. I used Morton's table salt. If you were to use like a natural, like a Himalayan salt, or one of the other ones, the kosher salts and stuff, you might get a higher concentration, which might help it work better or worse. These were kind of some of the source errors that I detected or that I came up with. I'm sure there might be others that I missed, but I think point of this assignment, objectively it was reached. We kind of learned some stuff about osmosis, and we actually get to see our gummy bears change and see that osmosis happening. So, all right, and this was my reference where I kind of learned a little bit about osmosis and the different types of tonicity and stuff. So, thank you for listening to my presentation.